A popular triangle to look at when we're dealing with right triangles is a 3, 4, 5 triangle. That's what is commonly used as the go-to Pythagorean triple. You'll see angle. So the question we have now in front of us is, what is this angle in a 3, 4, 5 triangle? What I'm going to do for this is I'm going to focus my attention specifically on my 4 and my 5. I only need two sides when I'm dealing with trigonometry. Two sides, I need one side and an angle, or two sides and I can calculate the angle, again, as long as I know I've got that 90 degrees in there, because so far our trig only works for right triangles. Now next week we'll talk about ones that are not right, and there's stuff for that. Wait and see. Dun dun dun! Right, so this problem here. What I'm going to be looking at is I want to come up with that angle, so I'm going to label my sides. Opposite from the angle I want to play with is my opposite. Across from 90 degrees is my hypotenuse. Next to the angle is that adjacent. So now I can look at this. I've got the opposite, I've got the hypotenuse. The question I want to ask is what trig function fits. And again, I selected the 4 and the 5 because I wanted to stay in what would be easy to work with. So I'm going to be using sine for this because it uses the opposite divided by the hypotenuse. So plug in what I know. Sine of the angle is equal to the opposite 4 divided by 5. Or sine of the angle is equal to 0.8. Now, as you recall from class, we've talked about the idea that if I tell the calculator an angle, it can look up the appropriate sine ratio. I put in a number like 30, the calculator will kick out a ratio like 0.5. I can ask the calculator to do the exact opposite of this. I hand it the ratio, it returns to me the degrees. So what I'm going to do is ask the calculator to do just that. I want this angle, theta, so I'm going to hand it the ratio of 0.8. Now this -1 is my way of telling everyone that I want the inverse. I want to do the opposite function. Normally, sine takes an angle, kicks out a ratio. I'm asking it this time to take a ratio and kick out an angle for me. So if I grab my calculator, I'm going to type in 0.8, and then I'm going to push whatever button I have to push to access sine -1. That's the inverse. And on most calculators, you'll see your sine button, and above it, it says sine -1. So I have to push the second function button, or the shift button, whatever button takes me up into that level. It's usually the same color. So if this is in white and this is in blue, then there'll be a blue button that says second function, which will kick me up to that level anyway, so I want that button up there. I tell it to do the second function of sine, and this returns to me an angle of 53 degrees. So that tells me that in this triangle, this 3, 4, 5 triangle, that this angle right here is going to be 53 degrees. I can use other things I know to find out what this angle is. I could do all this trig again, but I know that in any triangle the angles have to add to 180 degrees. So if this is 90 and this is 53, then the only thing left for this angle to be would have to be 37. Because remember, the sum of all three angles in a triangle must be 180 degrees. That little bit of memory saves me a lot of work if I want to come up with that third angle.